Okay, so today we are going to go through this subtopic, which is energy, work, and power. Okay, so we start with energy. Energy is the amount of work and it is measured in joules. Okay, so amount of work measured in joule. Okay, so for example, when you want to do work, you need energy. Okay, so we measure energy in joules. An object may have energy due to its motion or its position. So an object have energy when it is moving, so we call that kinetic energy. An object have energy when it is at a particular position, we call that gravitational potential energy. Okay, so we will learn that in details. So now let's see here. Conservations of energy. Energy cannot be created or destroyed. When work is done, energy is changed from one form to another. So from here you will see energy can change form, but they cannot destroy it. Okay, cannot just disappear like that. So it can change form. So for example, if you have let's say if you have a circuit with battery, and then after that a light bulb, for example. Okay, so what we can see here is the battery or the cell supply electrical energy. Okay, so of course electrical energy come from where? Come from chemical energy, which is where the chemical reaction happen inside the cell. So chemical energy change to electrical energy. So electrical energy will reach the light bulb and then it change to light energy plus heat energy. So it's something like that. Okay, so now let's see here. Energy can be stored. So energy can be stored. For example, the cell here, it stored the chemical energy. So now let's see here. Another example is like, for example, the hydroelectric dam. It stored the potential energy, gravitational potential energy. So when the water flow out from the dam, it generate electricity. So that is where the energy start to change from gravitational potential energy to the flowing of water, that is kinetic energy, and then they turn the turbine and then they generate electricity, and then that is electrical energy. So they keep changing form. Okay, now let's see the table. Kinetic energy due to motion. Example, when car is moving. So we have kinetic energy. Gravitational energy from potential to fall. So that means from a particular position, the object fall down. So it is where the gravitational energy change to other form of energy. For example, from gravitational energy to kinetic energy. So this is example, books on the shelf which fall down, for example. Okay, now chemical energy in chemical bonds. So examples is bonds in starch or food. So the covalent bonds in starch, in food, it has chemical energy. So when you consume that, when you eat that, so the chemical energy change to kinetic energy, so you can move around. Okay, you have energy to move around. Strain energy is due to the compressions or the stretching of something elastic. For example, the compression or stretching of the spring. Okay, so or elastic band. So you see, stretch elastic band. So you stretch elastic band and you put a stone over there. So then you release the elastic band, then the stone will start moving. That is where the strain energy change to kinetic energy. Okay. Nuclear energy is because the atoms, the nucleus of the atom, rearrange or split. Okay, rearrange or split. So release in nuclear plant. So nuclear plant is the nuclear factory. They release the nuclear energy normally because the nucleus join up or because the nucleus split apart, and then the nuclear energy is normally used to heat up water. So water becomes steam turn the turbines and then generate electricity. So in general it works in this way. And after that, internal energy is motions of molecules. We learn solid, liquid, gas, they vibrate, they move in random directions. So that is the motions of molecules. That is internal energy. But we also need to know that internal energy is not just the motion of the molecules. We also have the potential energy. So where internal is made of the motion of the molecules as well as the potential of the molecules. Potential is like the chemical bonds, chemicals interactions or chemical intermolecular forces, for example, of the molecules that provide the potential energy. So that is under internal energy. So I have to put it in this way first. So for now, internal energy we have the kinetic energy of molecules plus potential energy of molecules. So you can take it like this. The molecules are moving, so it has kinetic energy. The molecules have intermolecular forces that attract each other, that is the chemical energy. So both of these add up and we call that internal energy. Okay, now let's move on. Electrical energy carried by electrons. So electron that move causes electricity, so that is electrical energy. So for example, battery to bulb. So the battery makes the electron move and then carry the electrical energy to the bulb. Okay, now the next one, light energy carried in light wave. For example, from the sun, the light travel all the way from the sun to the earth. Okay, so sound energy carried in sound wave from speaker. So from the speaker all the way to our ear. Okay, so now let's move on. So we have so many kinds of energy, but we just need to know the formula for the kinetic energy and the gravitational potential energy. So kinetic energy, the formula is 1/2 times mass times velocity square. So Ke equal to half mv square. Gravitational potential energy equal to mass times gravity. This gravity should be the gravitational acceleration times height. Okay, so mgh. GPE equal to mgh. So we just need to know, how to use these two formula. So the formula for others energy is not what we need to concern yet. Okay, we just need to care about these two first. So example of conservations of energy. A book on the shelf has gravitational potential energy. If it fall off the shelf, it will have kinetic energy. So let's say I put it in this way. I give you some calculation. So let's say this is the shelf. The book is here. Okay, so let's say the height is 1.5 meter. The book, the mass of the book is, let's say, 0.8 kg. Okay, so when the book at that particular position, so it has gravitational potential energy, so which is mgh, so which is 0.8 times 9.81 times 1.5. Okay, so that is the gravitational potential energy. So after that, we just need to multiply. Okay, sorry, the G should use 10. Use 10. For A level, we use 9.81. For IGCSE, we use 10. Okay, so 0.8 times 10 times 1.5, so we get 12 joule. I get 12 joule. So this is the gravitational potential energy of the book. So now the books fall down. Okay, so the book fall off from the shelf, and when it almost reach the ground, so let's say they are asking the velocity of the book. So you can just put it in this way. The gravitational potential energy is changed to kinetic energy. So the 12 joule just now is equal to half mv squared, half 0.8 v power 2. Then we can use this to count the v. Okay, so imagine that 12 times 2 divided 0.8, then we square root, so we get square root, we get 5.48 meter per second. So that is the speed just before it touches the ground. So we can count it by using GPE equal to KE. So this is kind of popular actually. Okay, so we have done this part. Let's move on. Energy resources. So let's take a look. We have renewable sources and non-renewable sources. So first, renewable sources are not exhaustible. So that means you cannot use up, cannot finish. The energy cannot finish. Okay. Non-renewable sources of energy are exhaustible. So that means you will use up in near future. Okay, so for example, you can use up. Example is like fuel, the petroleum. So it's non-renewable. You use too faster than the formations of petroleum, which takes a long time. Okay, so that is non-renewable. Renewable, for example, like hydroelectric. Hydroelectric is renewable. You keep gathering water in the dam and change it to electricity. So that is renewable. Okay, now let's see the type. So fuel burn to make thermal energy, produces steam, turns turbine, and producing electricity. So this is the one of the famous way to generate electricity, although that is not so environment friendly, but it is cheap, it is plentiful, low tech, so you can easily get the electricity by burning coal, for example. Burning coal. Okay, so the disadvantages is harmful waste. Okay, the harmful waste causes greenhouse and pollutant gases. Greenhouse means carbon dioxide. Okay, carbon dioxide causes greenhouse effect. So greenhouse effect is where the carbon dioxide in the air trap the heat, making the surroundings to be hot. And then pollutant gases, we have pollutant gases like SO2, nitrogen oxides that causes acid rains. Okay, so radiations, so we also have radiation. So radiations make our skin not good. Maybe get skin cancer. Okay, so now we have wave energy. So wave energy, generators driven by up and down motions of wave at sea. So imagine the sea, the water go up and down. So at the meantime, it move the generators and generate electricity. Okay, so this is renewable sources. So the advantage, no greenhouse gases produced. Okay, so this wave energy is not so popular here, but maybe in other country. So with strong wave. Okay, so disadvantages, difficult to build. Okay, so tidal energy, dam built where river meets the sea, lake fills when tides come in and empties when tides goes out. Okay, so water flows and then run the generator. So you can see how we get the tidal energy. So tidal comes in during a particular periods of time, fill up the lake, and then after that the water from the lakes go out. Okay, then the water, when it goes out, it runs the generator and generate electricity. So no greenhouse gas produced. Same with this one. They are like using the natural resources basically. But expensive, can't be built every way. So depends on the amounts of water that flow out during the moment when the tide goes out. So we can't build anyway. Okay, so let's move on. So we have done everything here. The next page. Hydroelectric. River and rain filled up lake behind dam. Water release turns turbine, and then hence the generator generate electricity. So this is kind of famous in our place. Okay, so where it's something like this. You have the water dam. So the water dam, at the bottom of the water dam, so we let the water flow. So this is the water that we collect. Okay, so the water flow out and then turn the turbine. So the turbine start to spin. So imagine it spin because the water make it spin. Okay, so when it spin, it will generate electricity because at the back we have those magnet and solenoid. Okay, so of course we will learn that later. Magnet plus solenoid that generate electricity. Okay, so it is suitable in places where there is a lot of rainwater. So it's suitable, we can gather up the water easily. Okay, low impact on environment. Okay, so it just make the water flow, no carbon dioxide produced. Energy produced at constant rate. So it's you just keep controlling the amount of water that come out, so then it generate electricity at a constant rate. Few areas of the world suitable. So not suitable in places like desert, so no water. Okay. Geothermal. Water pumps down to hot rocks rising as steam. So geothermal is you have to penetrate very deep to the ground until the place where the ground is hot. So you put the water inside and heat up the water to change it to steam. So the steam will move the turbines basically. Okay, so no carbon dioxide is produced. That's the advantage. Deep drilling difficult and expensive. So you have to penetrate down to the earth. So that is difficult and expensive. Okay, so we use the heat from the center of the earth to make this work. Okay, now nuclear fissions. Nuclear fissions means the breakdown. Fission means breakdown. So I write at the side here. Fission is breakdown. Breakdown of what? Breakdown of nucleus of uranium atoms. Uranium atoms is an atoms with big nucleus actually. Inside there's a lot of protons and neutrons. Okay, so you make the nucleus break down, and when this happens, it will release a lot of nuclear energy. So how to make the nucleus break down? You have to shoot a neutron to the nucleus. So when a neutron enters the nucleus of uranium, it becomes not stable and break down. So produces a lot of energy with very little resources. You see, we just need a small little tiny neutrons to shoot the uranium, then it release energy. So we use a little bit of substance to generate a large amount of energy. So produces radioactive waste. So that's the problem. It is the radioactive stuff. So it generates radioactive waste. Radioactive waste means this waste will keep having radiations that produce from the waste, and then if human being is near to it, so they will exposed to the radiations and then get skin cancer. Okay, now next one, solar cell. Solar cell is suitable in places with a lot of sunlight. So make of material that deliver electrical currents when it absorbs light. Okay, so we have solar panels, absorb energy and use it to heat water. So the difference is solar cells absorb light to change it to electrical current. This one absorb light to heat up water. So it's a little bit different. So no matter how, no CO2 produced. Variable amount of sunshine in some countries. So it depends on the amount of sunlight. Okay, so it's kind of suitable here. Now let's move on. The sun is the source of energy for all our energy resources, except, this is important at this point, they like to ask in multiple choice. We discussed through so many kind of energy, so many kind of methods to generate energy. So which methods is related to sun? All of them are related to sun, because sun is the source of energy. Okay, all of them, except three of these. Geothermal. Geothermal is not related to sun because geothermal use the heat of the earth. Nuclear is not related to sun because nuclear use the uranium's atom, not related to the sun. Tidal also not related to the sun because tidal is maybe the moon and the earth, which have gravitational attractions that makes the water rise and drops. Okay, so it's the earth and the moon. Okay, so rather than the sun. Okay, now these three are not related to the sun. The rest are related to the sun. So for example, hydroelectric, how it related to the sun? The sun causes water to evaporate and causes raining happens, and then we can gather up the water in the dam because of the sun as the source of energy which heat up water. So that's an example. Okay, now in the sun, energy is created through a process called nuclear fusion. So you see the words fusion. Just now, nuclear fission. Nuclear fission is breakdown of nucleus. Nuclear fusion is combining nucleus. Combining nuclei. Nuclei means more than one nucleus. Okay, combining two nuclei, and then that is called nuclear fusion. So for example, you combine the hydrogen nuclei. This is what happens in the sun. The new hydrogen nuclei are pushed together and then they form helium. So you want to push them together, you need a lot of energy to make them move very, very fast and come together to form helium. So that's why the sun, which is hot enough, and this process can happen. Okay, so we have done here everything here. Okay, so until now we have done the theory part. Okay, theory part settled already. So what we need to do now is the questions. Okay, so these questions. Figure 3.1 shows a cabin used to transport passengers up a hillside. So you can see the cabin move up. Okay, the pulley is there. Now the cabin is attached to a cable which moves horizontally from A to B. Okay, so this is the station basically. So where the passengers can go into the cabin, and then after that it rises. Then up the hill from B to C, there is an electrical input of energy to the motor which move the cable. Okay, so the motor make the cable move. Place 2 takes against types of energy that increase as the cabin move horizontally at constant speed from A to B. Okay, so let's see. So they highlight a few words there. Move horizontally at constant speed from A to B. Okay, so now let's see. Kinetic energy of the cabin. So do we have energy that increase or not? So actually no. It is not increased. Kinetic energy is there. You see the formula for kinetic energy is kinetic energy equal to 1 over 2 mv squared. So if the speed is constant, that means this is constant, then the kinetic energy is also constant. So it's not increasing. We have to choose the one that is increasing. So we can't choose the first one. Gravitational potential energy of the cabin, the second one. So cannot also, because there is no change in the height. So the cabin is moving in horizontally. So cannot, because GPE equal to mgh. The h is not changing. Not increasing, then there is no increase in GPE. So gravitational potential energy of the cable. Okay, so gravitational potential energy of the cable. So likewise, the cable. So the cable, this is the cable. So the cable is moving in horizontal, so no change in the height. Internal energy of the surrounding. Internal energy of the surroundings. You see, if you eliminate these three, right, then we have to take on these two of course. So internal energy of the surrounding, yes. And why internal energy? Okay, so internal energy of the surrounding is related to the motion of the molecule, the gas molecule. okay, or intermolecular forces, intermolecular forces of the gas molecules. Okay, so do you think there is a change or not? Actually, yes. Imagine the cabin is moving in horizontal, so it creates some wind, some flowing of the gas, wind. So that is where the motion of the gas molecule increase, and hence the internal energy increase. Okay, now the next one, internal energy of the wires of the motor. Okay, of course you have to choose yes also. Internal energy of the wires of the motor. So how? The molecules in the wires, molecules or particles, in general I call it particles. Maybe you feel it's not molecules that are inside. Wire is made of metal, right? So I just call it particles. Particles in the wires are further apart. Okay, because you are stretching the wires in order to internal energy of the wires of the motor. We are not stretching the wire, we are stretching the cable. This is wires, wires of the motor. So the explanation is, wires is the one that carry electricity. So the electricity that carry in the wires make the wires hot, so the particles are move further apart because of the heat make the wire expand. So the particles in the wire are further apart, and then it affect the potential energy.
Can you repeat the last point? I still don't understand that.
Okay, yeah.
Is it the cable or the wires, and where is the wires?
The wires is something like this. Let's say you see the pictures here. Drive pulley connected to electric motor. So electric motor. So let's say the motor is here. So you want to connect the motor to the pulley. So of course we have to use wires. Okay, so these are the wires. Okay, so that is the thing. So initially we thought cable. So not the cable, it's the wires, not the cable. Okay, it's the wires that connect the motor to the pulleys. So the option there, internal energy of the wires of the motor. Okay, so how? First, like what I said, internal energy is made up of two parts, which is the kinetic energy of particles plus potential energy of particles. Kinetic energy of the particles is affected by the motion of the particles. Potential energy of the particles is affected by the intermolecular forces of the particles, or the separation of the particles. Okay, so if they are separate further apart, then the potential energy is getting greater, then internal energy increase, huh? So something like that. Okay, so you need to take this point first, then it makes sense afterwards. Okay, so first of all, the wires in the wires that join the motor and the drive pulley, so the wire is carrying electricity. Okay, so I put in a flow chart. Wires carries electricity, causes wire to be hot, and this make the particles in wires to separate further apart. When they separate further apart, now you see this, when it is separate further apart, the potential energy of the particle increase, the internal energy increase. Okay, so try to understand it through formula. So you get the idea now?
Yeah, kind of.
Okay.
Still not very clear.
Yeah, not very clear because you are not sure on what is internal energy. So that is the thing. Yeah. Okay. You are not sure on what is internal energy. So that's why it make you to be not able to take it. Yeah. So okay. Never mind. What you can do, just look at this video again. Listen to it a few more times to get the idea. Then at the end you'll be able to understand it. Okay. Now let's continue first. We look at part B. The cabin and passengers have a total mass of 800 kg. The vertical distance between B and C is 50 meter. 50 meter. So 50 meter is the vertical distance. You can see from here to here, the vertical distance. Calculate the increase of gravitational potential energy of the cabin and passengers when they move from B to C. Okay, so gravitational potential energy, the formula is mgh. The m is 800, the g is 10, the height we take vertical height 50, and we multiply them, we get 400,000 joule. So we put the answer here. Okay, so that's the thing.
This is the increase in gravitational potential energy.
Yes, correct. As there is an increase of height from B to C. Okay, so you look at the pictures at the same time to understand it. Okay, now let's see part C. So part C. The cabin then descends back from C to B. The weight of the cabin pulls the cable, which rotates the motor. The electric motor acts as a generator when rotate in this way. Okay, so that means it seems to be generating electricity when it comes down. So explain the environmental and economics benefits of this arrangement. When it generates electricity, of course, that is good, so the design is when the cabins come from C back to B, right? So the motor become a generator which generate electricity. Okay, so what is the benefits of having this kind of design? So first, electrical energy is generated. That's the benefit. The generator will generate electricity. So how we know that? You see, it's written here. The electric motor acts as a generator. Generator means generate electricity. So it use energy when the cabin move up, but when it come down, it generate electricity. So because of that, the other benefit is less energy is used overall. The next benefit, save cost.
So
Yeah.
how does it like when the cabin comes down from C to B?
Yeah.
How it generates electricity?
Of course, that design is not explained in details. In general, it's something like there is a decrease in gravitational potential energy, and they change the gravitational potential energy to electrical energy. Okay, so how it works, roughly to be like this. When it moves down, so the generator, right, should have something like magnet and solenoids that move around, so that the magnetic field is cut and generate electricity. It's roughly to be like that. Okay, should have that kind of design internally.
So when it goes from a B to C, how does it generate electricity?
It's not B to C, it's C to B.
Yeah, but if it goes from B to C, how does it generate electricity? Is it the same way as the cabin comes from C to B?
From B to C, it doesn't generate electricity.
So
From C to B, yes. When it comes down, it generates electricity. When it goes out, it uses electricity.
okay.
Yeah.
So it's something to do with motion now.
Yeah. The motions make the electricity to be
It's the one
induced.
that causing it to have electricity when it comes down from C to B.
Yes, true.
Okay.
Yeah. It's the motion that move the turbines, move the magnets and the solenoids basically. So try to imagine on that. Okay, so now let's come back to the third point just now. Save cost in moving the cable car. And one point as a backup point, less pollution to the environment. You see that give three marks, so we're supposed to give 3 points on it. So now we have 4 points here altogether. So you just need to put any 3 of these 4 points. Okay, so we settled ready for this one. Okay, now let's see what else. Okay, so question on page 18. Figure 4.1 is a simplified diagram of a geothermal power station. Simplified diagram. So you see what happened is very hot water from the ground. The ground, deep inside the ground, the rocks are hot. So it heat up the water and becomes steam. So the steam come here and move the turbine. So the turbine turns. Then what happens is there are magnets and solenoid inside, which the magnetic field is cut and then generate electricity. So generate electricity, then we have this transformer which increase the voltage, and then after that send the electricity to other places. Whereas the steam, right, after it turns the turbine, so it loses some energy already, it cool down. So it cool down, cooling tower is here, go back down to the rock to be heated up again, and then will come up as steam after that. So that is how the whole situation is. Okay. Now we look at part A. Describe the energy resource, label X in figure 4.1. So label X, so under the ground, right? So geothermal. Sorry? Fuel. It's not fuel actually, it's the geothermal. It's the hot, the center of the earth, which is hot, which makes the waters to change into steam. So we are not taking petroleum from here, no? We are not taking petroleum. Okay, because you see very hot water come out. It's not petroleum that come out, So we can't call it fuel over here. So don't misunderstand that. We are not penetrate to the ground to get the petroleum, but we are penetrate to the ground to reach a point where it is hot enough to make the water change into steam. Okay, so the answer for this is geothermal. Geothermal. Okay, now part B. Identify the useful energy transformation that takes place in the geothermal power station. Take one box in each column. Okay, so you see the input energy. So input energy, we have all this. So actually which one works here is the thermal energy. We penetrate down to the ground to make the water hot. So the rock underground, which is hot enough, supply the thermal energy. So we take this. So after that, output energy, electrical. So at the end, what we get is electrical energy. Okay. Part C. State 2 disadvantages of obtaining energy from fossil fuels. Fossil fuels is like petroleum. Okay, so the disadvantage is it is non-renewable.
Radiation.
Yeah, can cause radiation. Okay, that's fine. Pollution. Okay, so it causes greenhouse effect, or pollutant gases. Even when you write greenhouse effect, you get the marks already. Okay, so we have done for this part.